All right, welcome back. Hello again. Welcome to episode 7 now for building our very own video game using OpenGL and C++. In the previous episode, we went over our game structure, or how we are structuring all of our files, and or going over the EC pattern, and how our game is structured. In this episode, we're going to continue that, and we're going to work on the camera. So kind of what over the camera, and what I mean is we're going to have a little camera that follows our player around in our overworld, like so. Now, I did make a few changes in the meantime, so from what we were working on to now. So let's go over those real quick. And that is, I just changed the file names. So I moved our material renderer, shader, texture files into our EC folder. And then I gave them an extra name. So it's component-shader now instead of just shader. And then I added a namespace. So they're all in the namespace component. And yeah, you just got component material now. It's just so it's easier to, if you want to find a certain like a certain component, you just do component, and then it auto completes one of the 4 options or whatever options you have. So that will just make things nice and easy for quick and easy access to our components. Anyways, for this episode, we're not going to be dealing with that. What we are going to be dealing with is our camera function. And what that is we're going to be using the command pattern here, or a variant of the command pattern, since command patterns, I think, is one instance, which we will be using one instance commands in the future. But this is going to be multiple instance, but containerizing our different classes so that all the sort of components and stuff that we need is going to be contained in a class called system. So let's go ahead and define that here. It's going to be a component. So let's go call it component-system.h. And we will be including our component.h here. It's going to be in the namespace component, and which will be an interface. So let's call it iSystem. And that is going to implement our interface component here. And inside of our iSystem is just going to be a execute call, and well, we got to virtualize that. So virtual void execute here, and that is equal to 0 since it's not implemented. And then we will go ahead and start creating our first system here. And that is going to be our camera follow. So let's go ahead and define this component system camera follow. So we'll include our component system .h. Oh, if we can spell correctly. And like we were doing there, it's going to be in namespace component, and then we will have our first nested namespace here. So namespace system now, and class camera follow, public component iSystem. Let's go ahead and implement that execute function. So void execute override. And inside of our execute, we will just be updating our camera so that it changes the position of all of our different it's just going to be like an instance, like a rectangle, which encapsulates our screen, and we're going to move our screen around And then depending on like if we have like a tile map or other stuff that are based around the camera, we're going to update our camera position likewise. So to do that, let's go ahead and create also a component, and we're going to call that component position, and this is going to be our camera position. So we'll go ahead and include component.h class. I probably should have done this first before we started our camera follow, but oh well. Namespace component class position, and it's going to be a pretty bare bones sort of function here. It's just going to have, actually we could just have it, first off we gotta make sure it includes component here. We could just have it inherit GLM vec2, since it's going to be, our position is going to be functioning very similarly to that. And we might as well utilize the functions for that. GLM vec2. That way we don't have to implement like x and y as float values here. There we go. So let's go ahead and include our component position here. Whoops, there we go. And then, do we need anything else? We're going to need a component rect. So I guess we're going to have to define that as well. So let's go ahead and implement. So currently we have a rect.h, but it's not a component, and we don't want to make it a component because there's other things that we're going to be using the rect for. But we also want to be able to store a rect in our component system. So to do that, we're going to have to create a component rect. So we'll go ahead and do that here. Component rect.h, and we'll just include rect.h because it's going to implement our rect.h. So namespace, also include component.h. Namespace component and we can't call it rect because we already used that, so let's call this rectangle. Being really creative here. So public I component and public rect. There we go. Looking real good. So now we just have to update our camera based off of what our player position is. And our player position right now, if we go to our main, is defined under this rect dest, but we want to make sure it's actually kept in a component so we can edit and manage it using our EC game object, our game system. So let's go ahead and do that now. And another thing too with rectangle, I like defining like different use cases for it. So I have I think I use hashtag define, but I think there's a better, I think const express or using what is it? Be transform as rect. How do you define it? Hold on, give me one sec. All right, well, that took a lot longer than I thought it would. I was just looking up exactly how C++ deals with the define macro. I think you can just use define here. And that's completely fine, but it's a bit safer to be using using. So using what was it? Transform as equals to component or just rectangle. Whoops, let me... Yeah, we'll define it in there. So using transform is equal to rectangle and source is equal to rectangle. So these are just rect, but transform is kind of how it's locally perceived, and source is how it's perceived, or like what the source rect in the image. So what are we clipping out of our image and then putting on the screen. So that will just help with like defining a few things if we want, say like component transform. Is that going to work, or do I have to define using? Oh, here we go. Component transform, and this is going to be the follow rect, and then we also have so this is like distinguishing that we're using the transform rectangle, so we're not using the rectangle that it's clipping or whatever we have from the image. And the other thing that we are going to define here is the position. So we already have that here, so let's go ahead and define position, and this is the camera position. And then let's go ahead and implement those using our constructor. So camera follow, component transform, follow, and component position, and this is our camera position. So camera position, follow to follow. Pretty self-explanatory stuff here. And then camera position to camera position. So all we're really doing in our execute function here, so we're going to be calling this every single frame. So this is going to be like an update system. Let's see, in our frame here, we're going to just be setting our camera position to wherever the center part of our character onto the screen. So to do that, it is pretty easy. We just do camera position.x here is equal to the follower, or the follow dot x minus, and we'll static cast here this to float, and our width, I guess we could define width, but let's just hard code it. That's fine. 800.0f divided by 2.0f. So this is going to get half of the width of our screen. So we're doing 800 by 600 here. And that is going to add on, since we want to get the center of our character as well. So this is going to find the top right corner of our character, or top left corner of our character right now. So to get the center of our character, we also have to add the follower.width, or the follow.width, divided by 2.0f. And we'll do the same thing with our height, except replacing width with height, x with y. And that should update our camera position correctly. And then if we go outside of the bounds here, so say we go off in the 0 direction, we don't know exactly how tall it is in the opposite direction, and we could input that. However, we're going to be changing that in a bit anyways, so like how the camera works for that. So I figured it would just be easier to just leave it as a position and then only check for the lower bound. So if camera position.x is less than 0, we just set camera position.x to 0. And then likewise for y, if y is on the lower bound, we will just set it. So there we go. We have our first system set up. Congratulations. The next thing that we are going to do, I guess, is come up with a draw system. So what we're going to be doing is for our renderer, we have component system, and we'll do, so in our render system, since we're now rendering to the screen based upon the camera, we're going to have to change how exactly we're rendering here. So no longer drawing it from the main, but actually having a system or a component system handle that. So to do that, it's going to be component system draw .h. So let's go ahead and include component system namespace component namespace system, and let's do like that. So we have clean, consistent code, kind of. Then here we'll just call this camera draw, since we're drawing based off of where the camera is now. So if we want all of our objects to be drawn according to where the camera position is, we're going to have to draw based off of where the camera is. Pretty self-explanatory, I guess. This component iSystem here. And we're going to need a lot of different things in order to complete a draw. So if we remember correctly from our renderer, we're going to need a dest, a source, and a material. So let's go ahead and implement that. So our dest is going to be component transform, and that is going to be our dest. And we will need our source here, where we're clipping it from, source, and then our renderer, so what renderer we're going to be drawing towards. If we had multiple renderers, obviously we only have one. Our material, so what material, what shaders, what texture we're using. And that should do that. And then we also need our camera position, so we'll define that as well. So let's go ahead and define our camera position. And we'll get rid of those red squiggly lines very, very shortly. I'm sure they're annoying some of you. And we can do that all in one giant swoop by just including component renderer and component position, because I know we'll be needing that as well. Oh, interesting. I guess we also need component rect. There we go. So now we have a very long constructor to be defining here. Oh, spell that include correctly. Now we have a very long constructor to define. It's very tedious. In fact, I'm just going to copy and paste it in. Oh wait, actually, no, I'm not. No, I'm not going to do that, because I changed some of the names here because I'm dumb and I never have a consistent naming structure for a lot of my stuff. Let's do something like this. Dest. Copy and paste source here. renderer, go down to a new line, material, and position. I guess this is camera position, so we'll add a cam. We won't spell out camera because it's kind of tedious, I guess. And it looks like we forgot a comma here. Yep. In fact, maybe move this down a row. Move this down to third row. Oh, that looks really ugly. Oh well. And we'll do dest to dest, source to source, and so on and so forth. Renderer, renderer. And material to material. This is all extremely tedious and boring, and I'm sure anyone's actually watched this. I applaud you, not just skip to the end here. That's probably what I would do. Cam position. And then we will finally actually override our execute function here, which we'll be dealing with some extremely boring stuff again. So to do that, we are going to need a temp rect in order for what we're going to be rendering towards. So we'll do that here. Define rect. We'll just call it dest. I guess let's call it temp dest actually, because we have dest defined. And temp dest is just going to be temp dest dot bakes is equal to transform dest dot x minus camera position cam position dot x. So we're just offsetting our position by our camera position. So just have two different x and y coordinates here since we're not dealing with 3D. And now our temp dest, well, I guess we have to also set dot w is equal to dest dot w. Same for height. Whoa, there we go. Now we can just do our renderer.jaw, and it's the same as what we did in our main in the previous, I think 2 episodes back we did this. It's been a while. So source, and now temp dest we're going to pass through here. And then lastly, our material. So it's going to be material like so. And wow, look at that. Finished our camera draw now. So we have our camera follow and our camera draw. Now we just have to implement our different... do I have to do anything else? Do I have to define our map or anything like that? I don't think so. I guess we have to set up a new thingamajig. But this episode's kind of long, and this actually does look like it's going to take a bit of time to go over. So let me go ahead and run this just to see if everything is compiling correctly. And it looks like it is. And we will be implementing our entity component setup in the next episode. For now, I'm just going to call it. And let me just bring back the camera. Hello again. So for this episode, I'm going to call it for now. Let me know, you guys, if you guys have any questions, any comments, anything you want explained a bit better, any feedback. Am I too boring? I probably am. That's that's a given. Anyways, thank you guys so much for watching, and I'll see you in the next part.